Hey, what's up, guys? Jung here again. So today let's take a look at one of the a weekly contest problem, number 1577. A number of ways where square of number is equal to product of two numbers. I think it's a pretty good problem. So basically, you're given like two arrays, right? Array nums1 and array nums2, and it asks you to find all the triplets, basically all the triplets type 1 and type 2. Okay, so for type 1, basically what it's doing here is you pick one number from nums1, and then you pick two numbers from nums2. See the nums is the index is different, where the square of the number from number nums1 equals to the product of those two numbers from nums2. The type 2 is just in the opposite way. Basically, from from type 2, you pick one number from num2 and then do the square, and you're looking for a pair from nums1 to find the number where the product the same as the square. Yeah, that's why. So for the nums1, for the example one here, right? There's only one triplet. Basically, you pick 4 from nums1, and then you pick uh 2 and 8 from nums2. Okay, and example 2, you have 9 options. The reason being is because you can pick one, and then you have a 1, 2, 3, 4. Basically, all the combinations they're all equal, right? And if there's nothing, if there's no way, no such triplets, you just simply return 0. Okay, and the the length, right? So the length is like it's 1000. Okay, the length of the tool is 1000. So which means you should use like n square, right? If you use uh, n cube, that will be too much. Okay. So I mean, a brute force way is what? Basically, a brute force way will be you simply pick each number in nums1. Okay, and then from nums2, right? You just all the uh, loop through all the combinations, right? All the pairs from nums2, which will be also like n squared, right? And then you just find, okay, if I ever find like a triplet, right? And then I increase the answer by 1. Okay, so basically you loop through all the numbers, and then you do a, a nested for loop to find the pairs in nums2, and then you do it reversely, and then you do the same thing. You pick one number from nums2, and then you find all the pairs in nums1. Okay, so that's gonna be what? So that time complexity is gonna be to loop through each number in nums1 is gonna be n, right? To find all the pairs, right? For uh, in nums2 it's gonna be a n square. So in total it's gonna be a n cube, right? That's gonna be too much, right? So we have to find a better way of doing this. Okay, so a, a better way, an improved algorithm will be we can pre-process all the all the results, right? Since we can pre-process each of the nums here, nums array here, we can find all the pairs, right, in advance. And since we have the pair, we can we can get the product of those pairs, right? And then we can simply store store the the count for each pair. Let's say, for example, let's say we have a so from nums2 here, let's say we have a count. So basically, the key in the dictionary will be the product, and the value will be the number of pairs that have the same products. So basically, let's say if the product is 4, the product is 8. Let's say the 8 has like the value is like three counts. Okay, so this means that in nums2, uh, we have three pairs that have the product equals to 8. Okay, okay, so after we have built this like dictionary or hash map, now when we loop through the nums1 here, we can simply use this this number, the square of the number, and then trying to look for the count, right? The count from the nums2 hash table. And then we can simply add this count to our final answer, right? So in that way, actually we reduce, since we pre-process all the pairs. Now it's going to be the n square plus n, right? Which will be the n square time complexity. That will work. Cool. So I think we can start coding here. All right. So like I said, we need the answer here, right? And then n1 equals to nums1 and n2 equals to length nums2. Okay. What else? Nums1 product. Okay. Default dict int and nums2 product also default, right? So now we need to pre-process those products. Basically, I'm going to just have a loop here, n1 minus 1. Okay, this is how we uh, loop through all the pairs, right? Since we need another like place for the next number, that's why we stop at n1 minus 2. Okay, for j in range I plus 1 and to n1. Okay, and then we have nums1 dot product. Okay, the key will be what? The key will be nums I times nums j, right? And the value will just basically increase. Okay, so and same thing for for the other array here. Basically n2 n2 to yeah. Okay, so now we have the we have the products for those numbers. Now we simply need to loop through the numbers, right, on each of the array here. Okay, and then we have a target, right? The target is what? Num1 square, right? And then do answer plus we're going to look for the target from the nums2 product dictionary. Okay, target. If it's not there, it's fine, right? Because we have like a default dict equals to integer, right? We already set the default value here. So even if the target is not in here, this one will return us a 0. Okay. Same thing for the nums2. But in this case, we'll be looking for the target in nums1 product hash table. Okay. Okay. Yep. And in the end, we simply return the answer. Cool. So yeah, this should work. Let's try to run the code here. Oh, sorry. In. Oh, 1, 1, 2, 2. Okay. All right. Cool. So submit. Cool. So accepted. All right. Yeah. So it's uh pretty straightforward. Like what can you call this? Like a counting or like hash table problem, right? Basically, we just a little trick here. We just need to pre-process all the products, right? and then store those products into a hash table with the key equals to product and the value is the number of the pairs for that product on in each of the arrays. And then later on, we can simply use the pre-processed results and then so that we can reduce our time complexity, right, from n cubed to n square. Uh, yeah, I think that's pretty much it is for this problem. Yeah, thank you so much for watching the videos, guys. Stay tuned. See you guys soon. Bye bye.